in order to solve for sides, okay? And we'll be setting up some ratios here too. So similar polygons are polygons with the same shape, but not necessarily the same size. Okay, so similar does not mean the same as congruent. Okay, with our congruent polygons, they had to be the same size and shape. Okay, this one, they have to be the same shape, but not necessarily the same size. Okay, the symbol for similar is this wave here. Okay, so it's kind of like congruency without the equal sign. Okay, you have to add that symbol there. So the definition of similar polygons is two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. Okay, so in similar polygons, your angles are congruent. Okay, that's why when we were trying to prove triangles congruent to each other, we didn't have an angle, 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 because that could mean they're similar but not necessarily congruent. Okay, in this case, for similar polygons, you have to have all of your angles congruent to each other. Okay, but your sides then are just proportional, meaning they have the same ratio. So our first example here of similar polygons, if we have triangle ABC similar to triangle XYZ, we want to list all pairs of congruent angles and write a proportion that relates to the corresponding sides. So just like with congruent triangles, we do have a similarity statement. Okay, that is just what they used right here. Okay, so your similarity statement would be triangle ABC is similar to triangle XYZ. Okay, and just like with your congruency statement, it does have to go in a specific order. Okay, so if I go from A to B to C, then I have to go X to Y to Z. So my congruent angles then, since I have angle A here, started with angle A, its congruent angle would be angle X. Okay, so we know A is congruent to X. Then we have angle B. Okay, angle B would have to be congruent to angle Y. And then angle C would have to be congruent to angle Z. Okay, and we can just use our similarity statement to help us find those congruent angles. Okay, the next piece we wanted to see was the proportion. So the proportion has to do with the sides of your similar triangles or similar polygons. So in this case, I would say AB over its similar side would be XY. Okay, so these two sides are similar, so I can make a ratio of those similar sides. Okay, that has to be equal to side BC over its similar side, which is YZ. Okay. And then last one, I would say side AC over its similar side of XZ. Okay, so all of those ratios of those similar sides have to be equal to each other. Okay, so that's one way we can show that your polygons are similar as well. Okay, if they all have those equal ratios of sides. Okay, questions so far? All right, then in example 2, we do want to determine whether the pair of figures is similar. So to do that, we have to show that your corresponding angles are congruent and your corresponding sides are proportional. So if our first step here is to compare our corresponding angles. So if I have angle W, looking here, I have this marker right here, that symbol. in my other polygon, that would be angle P, right? So I can say angle W is congruent to angle P. Okay, looking at angle X, okay, that has 4 arcs there. So looking for the other angle that would be congruent to that one, that would be angle Q. Angle Y has 3, so does angle R. Okay, so those two would have to be congruent. And then the last one, angle Z, has 2, and S has 2. So those two angles are congruent. So my first step in determining whether these polygons are similar is finding all of those congruent angles. Okay, making sure they are congruent. Okay, so since I do have all my congruent angles, your corresponding angles are congruent. That's the first part. The second part is looking at your corresponding sides and making sure that they're the same ratio. Okay, so I have this first one done here. We have WX over PQ. So WX over PQ. This time I do have lengths of these sides. So I would say this is 12 over 8. Okay, so that's my ratio of similar sides, and I can reduce that to 3 over 2. Okay, we want to do the same thing to all my other similar sides. So I have XY over QR. Okay, those two are your similar sides. So I would say 18 over 12. Okay, and I do want to reduce this ratio just like we did last week. Okay, both of those numbers do divide by 6 to get 3 over 2. Okay, my next pair of similar sides here would be YZ over RS. Okay, so YZ is 15 over RS is 10. Okay, what is this ratio reduced to? Yep, 3/2. Okay, then my last pair of similar sides are ZW and SP. So ZW is 9 and SP is 6. Okay, again, reduce that ratio. It does reduce to 3/2. Now this is why I do need you to reduce the ratio, because when you're comparing these sides, they all have to be the same ratio. Okay, if they are not, they're not similar polygons. Okay, they have to have that same ratio. So since corresponding sides are proportional, hence the same ratio, these two polygons are similar. Now, the polygons are similar with a scale factor of 3/2. So your scale factor is the ratio of two corresponding sides of a similar polygon. Okay, so that ratio you get all of the sides to be is called your scale factor. Okay, so make sure you do remember that. Some practice problems ask you to find a scale factor. Okay, so that would just be the ratio from similar sides in each polygon. Okay, any questions so far setting up your ratios of similar sides? All right, then I'm going to skip the top one and I'm just going to move on to this one right here. Okay, so you can use scale factors and proportions to find missing side lengths in polygons. Okay, so this is where we're going to set up a proportion where we already know our polygons are similar to each other in order to solve for a side. So in example 3, the two polygons are similar. We want to find x and y, and we are using the congruent angles to write the corresponding vertices in order. So so we have RST would be similar to, since I started with R, I have to start with M. I went to S, so I have to move to N. And then to T, so I'll go to P. Okay, so I'm just using those congruent angles labeled in each triangle to write that similarity statement. So now what I want to do is write out proportions to solve for x and y. So I'm going to solve for x first. Okay, so my first step in solving this problem is to look for a ratio of similar sides that doesn't have a variable in it. Okay, that ratio sides would be RS and MN. Okay, so those two sides there are similar to each other and they don't contain a variable. So that means I want to use that ratio in order to set up a proportion. So finding x here, I could set 32 over 16. So I just went from the larger triangle to the smaller triangle, set up that ratio of similar sides. Well, that has to equal, okay, the ratio containing x and its similar side. Okay, so x is right here of ST. And since I started with 32, I need to start with x. Okay, so you can't flip-flop back and forth. Whichever one you start with, you have to start with in your other ratio as well. So what side is similar to side ST in my other triangle? NP. So I'd set x over 13. Okay, so now that I have my proportions set up, I can cross multiply. Okay, so I have 16 times x is equal to 32 times 13, which is 416. Okay, then I just have to divide both sides by 16. And x will equal 26. Okay, so that was finding x. Next, I want to solve for y. So since all of my sides are proportional, I can just use that same ratio that I used to solve for x. Okay, so my original ratio here was side SR over side NM. So we have 32 over 16. Okay, now what ratio would I have to set this equal to solve for side y here? 38 and y. Okay, what order does that go in? 38 over y. Okay, so since I started with 32 in that first ratio, I have to start with 38 in the second one because that's in that larger triangle there. Okay, so now from here, again, all I have to do is cross multiply like we did last week. So we end up with 32y is equal to 16 times 38 is 608. Divide both sides by 32. And y equals 19. Okay, so you do have to be careful when you're setting up your proportion. Whichever triangle you start with in that first ratio, you have to start with in that second ratio. Okay, any questions on example 3? All right, then moving on here, the scale factor is the same as the ratio of the perimeters. So what this is saying is that your scale factor you find in your similar triangles. Okay, so For this one over here, it would have been 2 over 1, right? Okay, that would have been my scale factor for this problem. That scale factor is the same as the scale factor of your perimeters. Okay, so you can find the perimeter of one of them and then find the scale factor between your sides to find the perimeter of the other polygon. So that's what we're going to do in example 4. So if you have triangle DEF is similar to triangle GHJ, so DEF to GHJ, find the scale factor of triangle DEF to triangle GHJ. Make sure this is in the correct order for your scale factor. So it wants this triangle first over this triangle second. Okay, so make sure you're writing your ratio in the correct order. And we want to find the perimeter of each triangle. So first, what we want to do is find the scale factor. To find the scale factor, we want to find our similar sides between our two triangles. Well, my similar sides in this case would be EF and HJ. Okay? And since I'm writing my ratio as triangle DEF to GHJ, I need to write this side first. Okay, so my scale factor, I'd have 8 over 12. And I can reduce this, okay, to 2/3. Okay, so my scale factor between my two similar triangles is 2 to 3. So next, I do want to find the perimeter of triangle DEF since I have all three sides. Okay, to find that perimeter, we just need to add them all together. So we have 10 plus 8 plus 12. Okay, that equals 30. Now, there are two ways you could do this. One takes longer, the other doesn't take as long. So you could set up proportions to solve for these two sides and then add them all together, kind of like what we did in this example up here. We found those remaining sides in order to add them together to find the perimeter. But since our scale factor is the same ratio as that perimeter, to find the perimeter of GHJ, we're going to take our scale factor of 2 to 3. Okay. Set it equal to the ratio of our perimeter. So since I started with triangle DEF here, I'm going to start with that perimeter, which we found was 30, over the perimeter of GHJ, which is what I'm trying to find. Okay, so our scale factor is the same as the ratio of that perimeter. So from here, I can just cross multiply. So I have 2x is equal to 90. Divide by 2, and x is 45. Okay, so the perimeter of triangle GHJ would be 45. Okay, so you just have to find the scale factor of your similar sides, set it equal to that ratio of your perimeters. So you just need one of those triangles' perimeters to find the other. Questions on example 4? Okay, just a couple more problems here then. So for these 3 problems at the bottom, you want to find the proportion and solve for the value of x. Okay, so each polygon is similar. It's already given to you that all 3 are similar. So what we want to do is set up proportions just like we did in example 3 above to solve for that variable. So number 1, I'm going to help you out with this one, and then I'm going to have you do the other ones. So number 1, what I want to do first is find my 2 similar sides between my triangles here that have a number to write that scale factor. Okay, so my similar sides would be this side of 40 and this side of 30. Okay, so those two sides I could create that scale factor with. So I'm going to start with that larger triangle first. So I can take 40 over its similar side of 30. Okay, set that equal to, since I'm trying to solve for x, and x is in this length right here, I need to use that side over its similar side, and its similar side would have to be 18 in my other triangle. So since I started with 40, I need to start with x plus 15, okay, over its similar side of 18. Okay, now that I have my proportions set up, I can just cross multiply, making sure that I distribute that 30 to both the x and the 15. Okay, so I end up with 30x plus 450 is equal to 40 times 18 is 720. Subtract 450 from both sides. To get 270. And then divide both sides by 30. And x is equal to 9. Okay, so all you have to do is set up a proportion to solve for that missing side in those similar triangles. Okay, questions on that first one on the bottom there? Okay, then I want you guys to try 2 and 3. And then I'll go over those. Can you find it at 5 over 10 right, I'm going to go through these last two problems here. So in number 2, my proportion that I set up was 10 over 5. So I took this side over its similar side. Okay, is equal to, since I started with 10 here, I'm going to start with 4.5 in this one over its similar side, which is x. Okay, so from here I'm just going to cross multiply. So I have 10x is equal to 22.5. Divide by 10. To get x is equal to 2.25. Okay, then the last one here I set up as 12 over 18 is equal to x plus 1 over 24. Okay, from here just cross multiply. So we have 288 is equal to 18x plus 18. Again, make sure you distribute. So I have 270 is equal to 18x. Divide by 18. And you do get x is equal to 15. Okay, any questions?